Hello guys, welcome to Coding. In this video, we are going to see the Leetcode problem number 1971. Find if path exists in graph. Let's get into the problem. So the problem statement is there is a bidirectional graph with n vertices where each vertex is labeled from 0 to n minus 1. So each edge, the edges in the graph are represented in 2D integer array edges where each edge will be containing the source and destination. So there are two vertexes. So it will help us to identify that there is an edge between two nodes. So yeah, as denotes a bidirectional edge between ui and vi vertex. So each vertex pair is scattered by at most one edge. So there are no duplicate edges and no vertex has edge to itself. That is, there is no cycle present in the graph. You want to determine if there is a valid path that exists from vertex source to vertex destination. Given the edges and the integers n, source and destination, return true if there is a valid path from source to destination or false otherwise. So this is all about our problem statement. So let's get on to the problem definition and the approach. So the first step to solve any problem is to define the problem clearly. So the input for this problem is n edges, which is a two-dimensional matrix, and source and destination. These are the input we get, and the output we need to find out is if there is a path between source and the destination. So this is the output and input for our problem. So let's find out what are the other problem statement given here. So the graph is bidirectional. So the first point is this is a bidirectional graph. So bidirectional graph means nothing but if there is, so let's say this is vertex 1 and this is a vertex 2. If there is an edge between vertex 1 and vertex 2, so it will mean that we can reach vertex 2 from vertex 1 and also we can reach vertex 1 from vertex 2. So this is the meaning here, and this is the other points here. So each vertex are labeled from 0 to n minus 1. So vertex label, so vertex labels are 0 to n minus 1. What are the other points? So each edge will be containing each edge will be containing two nodes, that is vertex 1 and vertex 2. It will mean that there is an edge between v1 and v2. This is what it's meaning. Yeah. So every vertex is connected to at most one edge, and there is no vertex has an edge to itself. So we need to determine whether there is a path between source and destination. So yeah, this is all about our problem definition. Now let's move on to approach of this problem solution. So the second step is the approach to solve this problem. So there are n number of nodes present in the graph. So there is a source node and there is also a destination node. So we need to find whether there is a path from source to destination. This is what we need to find. So when we consider the source and destination, there are two possible ways to reach the source destination from the source. That is, there may be direct path from source to destination, or else there may be another nodes in between. There may be intermediate nodes, any number of intermediate nodes, and it will be reaching the destination. There are only two possible ways. So how can we determine this? So in order to move from source to destination, we need to know the neighbors, that is the nodes that can be reachable from each node. So when we consider the source node, we need to find the neighbors of the source node, and if the neighbor of the source node is itself a destination node, we can easily return true. So it will determine, it will be denoting that there is a direct path between source and destination. So consider the cases in which the source node neighbors doesn't have destination node. So in this case, we cannot return true. So in this case, we need to visit the neighbors. So other neighbors, other nodes except the destination. So before that, we'll discuss what the graph is. So what is a graph? So graph is nothing but there will be a number of graph will be containing of two components. So the two components, they are node and edges. So the node, let's denote the node as a round symbol and edges as a line. So the edges may be linking two nodes. It also may be uh, linking the same node, which will lead us to cycle. And the edges are also of two types, which is directed edges and undirected edges. So here it is a direct undirected edges because there are two possible ways for graph traversal. Maybe the node can reach, any node can reach each other nodes if there is an edge between them. In case of directed edge, only the direction, the traversal can happen only in the direction of the edge. So this is all about the outline of graph. So we are requested to find the, we will be given the nodes, and we are also given the source and a destination. Let's say there's a source, this is a source and this is a destination. So we need to find out whether there is a path between source and destination. So in this graph we can see that there's a path between source and destination, so we'll return true. So this is what we are asked to find out. Let's see how to approach. We clearly know that we need to find out the source and the neighbors of each node. So the first step is to find the neighbors of each node. Find neighbors of each node. So if we find the neighbors of each node, let's say this is the source node. So there may be any number of neighbors. So we need to find all the neighbors of the source. So there are two ways to traverse over the graph. They are DFS and BFS. So what we can do is for this problem, we can go traverse level by level and find out whether the destination the destination is reachable or not. So this is what we are going to find out. Um, we are going to use the BFS approach and not the DFS approach. So BFS approach helps us to traverse over the graph level by level, and DFS helps to traverse the graph. Traverse means it's nothing but visiting each nodes. So traverse the nodes by depth by depth. we'll go complete depth and return back to the previous depth and move to the other edges. So this is what we are going to do. So we are using BFS approach because BFS approach is a time wastage because if let's consider the source and in destination is present in the first level, and let's consider many other nodes. So in this case, what DFS does is it will go to the neighbor, other neighbor, return back, go to other neighbor, return back, other neighbor. So it's going depth by depth, and finally we are able to reach the destination. So this will cost us n time complexity. But in case of level order reversal, we'll go level by level. So in the same graph, we'll go firstly we are in current first level. Now we'll move on to second level. So in second level, we'll be able to find out the destination node. So we'll stop the iteration here, and we don't traverse over other nodes. So we can stop the iteration here and return. So that's why we are going to choose the BFS. Yeah, that's it. So what we can do is find the neighbors of each node, and we'll find the neighbors of each node, and after that we are going to create a queue. So we need a queue to go use the BFS traversal, and we also have a visited array. So we need a visited array because since firstly we'll add the source node to the queue, and after we move to next level. So uh, in order to move to the next level, we'll traverse over the neighbors of the current level. So the neighbors of source node will be let's say this number 1, 2, 3, and 4. So when we visit all these nodes, we need to find for the other that is the neighbors of these nodes. So the neighbors of nodes 1, 2, 3, and 4. In when we consider the neighbor of node 1, the source node is also the neighbor. So we don't need to go back to the previous level. We need to go only level next level, move on higher levels. In order to do that, we need to keep track of the visited nodes. If the node is already visited, we don't add the we don't need to visit the same node. So we'll create a set visited set, which will be containing nodes that are visited. And the fourth step is add source node into the queue. And fifth step and the fifth step is to traverse unvisited nodes level by level. And if destination node is found, the node is visited, return true. And if destination not reachable, return false. So these are the steps and used in our approach. So let's consider an example for our approach. So let's consider the given example. So this is the example. So we are given n nodes. There is 3 nodes. So there is 3 edges, right? So 3 nodes will be 0, 1 and 2. So there is an edge between 0 and 1. There is an edge between 1 and 2. There is an edge between 0 and 2. So source is 0 and destination is 2. So initially we'll create a queue, right? And we also have a set, visitor set, let's say v. So that's a visitor set. And initially we'll add the source node to the queue. So we are adding source node and also we are adding set. The node is we are marking the 0th node as visitor. Now we are going to next level. So in the next level, that is the neighbor of 2 will be 2, 1, 1. So we'll add 2 and 1 to the queue and also 2, 1, 1 to the visitor set. Now we'll pop all the elements from the queue. In doing that, we can find out 2 is the destination node. So we'll return 2. So the answer is true. Let's consider another example. This is the example 1. Now we are finding the answer for example 2. So there are 6 nodes. So the nodes will number from 0 to 5. So 0, 1, 2, 3, 4 and 5. So there is an edge between 0 and 1. There's an edge between 0 and 2, 3, 5 and 5, 4 and also 4, 3. So that's all. Edges are over. Now the source is 0, node 0 and destination is node 5. This is the destination. Source and destination. Now we'll use another paint. Let's use red color. So we'll have a queue which is empty and also visited set. So initially we'll add the source node. So source node is added. We'll add the destination of the source node, which is 1 and 2. So we'll go to 1 and 2. We are unvisited. We are adding the nodes, that is visitor node, to the set. Now we need to find the we have reached the second level. Now we need to check for the there is traverse for the neighbors of the current level nodes. So once neighbor is 0, which is already visited, so we don't add the 0 node to the queue. Now we are moving to the other node 2. So 2 is having the neighbor as 0. So 0 is already visited. So we are stopping the iteration and we can see that we have emptied the queue and there is no destination node reach. So this will help us to know that there is no path from source to source to destination. So we'll return false. So that's all, guys. This is our demonstration of our approach. Now let's see what is the time and space complexity of this approach. So time and space. So the time complexity of this approach is big O of n, and the space complexity of this approach is big O of n. So this is all about our time and space complexity. An approach we have used here is BFS. So that's it, guys. Now let's get on to the coding section. There you'll get the clear idea of how to implement this approach. So initially we'll create a queue of integer, let's say nodes. Now we'll create a set of integer visitor. We have named the set as visitor, so we'll let it be a hash. Yeah, we have created this, and we need to store the neighbors of each node, right? So in order to store the neighbors of each node, we'll create a map of integer comma list of integer. So neighbors. So we can name this as neighbors, and we'll have it as a new hash map. Now we'll store neighbors. We'll pass the neighbors and n neighbors and edges. After storing the neighbors, the second step is to enter the source to the queue. So now start add source, and we'll also mark the source node as visitor. So adding the source to the visitor set. Now we are sitting on visitor nodes, while nodes is not empty. We'll find the size of the current level nodes. So node start size, and we'll iterate over each node, and we'll poll the node. So current node will be nodes dot poll. So if the node that is visited is destination node, if node equals destination, will return true, or else we'll add the neighbors of the node. So we'll have a helper function, add neighbors, along with we'll also pass the neighbors and queue this nodes and visitor nodes. So visitor, and we'll continue. So finally, if the destination node is not unvisited, that is not reachable, will return false. So let's write the helper function. The first helper function is store neighbors. So wait for n number of nodes. Neighbors is nothing but map of integer comma list of integer neighbors comma edges. So initially we are going to create n nodes. So we are going to store the n nodes here into the neighbors map. So for I equal to 0, I less than n I plus plus. So we are creating an empty list for each node. So put I comma new empty list. After this we are going to store the neighbors. So we are going to iterate each edges. We'll iterate over using enhanced for loop, and we'll have u as edge of 0. First node is taken as u, and second node is v, and we are taking the adding the edge v as neighbor to u, and u is a neighbor to v. So we are going to add add the neighbors to both of the node. So neighbors dot get u will get us the neighbors of u, and we are adding the node v to it, and neighbors dot get v will get us the neighbors of node v, and we are adding the node u. So it's done here, and we are going to write the last helper function, which is add neighbors. So map integer comma list of integer, so set of integer shitter and q of integer. So now to add neighbor, what we'll do is we'll fetch the, so instead of writing helper function, we can do this directly here. So we'll firstly get the neighbors of the current node. So list of integer current neighbors is nothing but neighbors dot get current node. So we are iterating using a for loop in neighbor current neighbors. Uh, Current, we are iterating over each neighbor, and if it is already visited, so visitor dot contains neighbor will continue, or else we'll add the node to the that is the will add the neighbor to the queue. So add neighbor, and we also add the node to, that is the neighbor to the visitor node. So we'll remove this. So I think we have done the coding here. So what we are doing here is firstly we are creating a queue, and we are also having a set visitor and also map to store the neighbors of each node. So we are calling a helper function to store the neighbors of each node, and we are adding the source node to the queue and also the set. And after that we are going to use a while loop to iterate over each level. So initially we are at first level. So in the first level we are going to find the size of the level, and size of the nodes present in the current level, and for each node we are going to poll the node, and if the node is destination we are returning to, or else we don't need this. Since we have directly added the neighbors here, there is unvisited neighbors. If there is nothing but adding the unvisited neighbors of current node, which is node here, node variable here. So this is the node variable will denote the current node here, and we are getting the current neighbors. So if for each neighbor we are checking whether the neighbor is already visited or not. If it is visited, we are continuing, or else we are adding the node to the queue and also the visited set. So this is all about our the valid path function. Now we are going to see the store neighbors helper function. In the store neighbor helper function, initially we are creating the entry for each of the nodes, that is for n nodes ranging from 0 to n minus 1. We are going to create a empty list denoting the neighbors, and we are going to iterate over each edge and add the neighbors to the each of the two nodes present in each edge. So one edge will be having two nodes. So we are linking the two nodes by adding to the neighbors list. So that's it, and let's take this. So we're working for sample test case. Let's submit it up. Accepted. And there is a little bit optimization that can be used here. So instead of using set, you can use an integer array of size n. In this array, what we can do is instead of this, we can mark it as, so let's have it as a visitor. So we need only a boolean value, right, for each node, whether it is visited or not. So initially the value of every node will be false, so every node is unvisited, so every node value in the visitor array will be false. Initially we are going to mark every node as true when the node is visited. So visited of source is turned to true, and in order to check whether the node is already visited, we can just check the index of the node. So if the node is visited, we'll continue, and or else we'll add the node to the queue, and also we'll mark the node as visitor. So in order to mark node as visitor, we'll change the value of the node to true. So let's see. So let's take this. It's working fine. Let's submit it up. Accepted. And that's all about this problem, guys. Thanks for watching this video. Have a great time.